Okay, hello everybody. We're going to try to explain how to use Cramer's rule to solve a system of equations. So I've already written a system of equations, generally speaking, up here. So this is basically a linear equation in x and y. So this basically is a1 times x plus b1 times y equals c1, where a1, b1, and c1 are constants. The same thing with the second line, where a2, b2, and c2 are constants. So this really represents two lines on a two-dimensional space, and we're trying to figure out what specific point they're intersecting. So, if I'm going to figure out what the solution to the system of equations is by using Cramer's rule, what I have to do is basically show what D represents. So D is basically the determinant of the coefficient matrix. So our coefficients are basically A1, B1, A2, B2 in the second row. Okay, now in finding a determinant of a 2 by 2 matrix, it's simply you take the diagonal that involves A1 and B2, you take that product and you subtract the product of A2 times B1. So writing this out, it would look like this. A1 times B2 minus A2 times B1. Okay? So, in trying to figure out what D sub x is, D sub x, if you can imagine, we take the original coefficient matrix, and what we do is we replace the x coefficients with the c's. So A1 and A2, which usually would go here if we're trying to find out what D is, they would be replaced by our constants. So D sub x, replace the x coefficients with the constants. So C1 and C2 go here, and B1 and B2 is the column that we do not do anything to. We just leave it as it is, just as it is in the original coefficient matrix. So you see, basically I've taken these values, A1 and A2, and replaced them with C1 and C2. That's going to give us what's called D sub x. So, again, using the same technique to find out what the determinant is for this 2 by 2 matrix, we take this diagonal, the product of this diagonal, minus the product of this diagonal. So that would give us C1 times B2 minus C2 times B1. This times this minus this times this. D sub y, can almost imagine what it's going to be. It's going to follow the same rule that we followed for D sub x, meaning that instead of having the c coefficients in this spot over here, sorry, the y coefficients in the spot over here, we replace them with our constants. So for D sub y, we replace the y coefficients with our constants. So these two end up here, where the y coefficients were. So here's where C1 and C2 will end up. And again, since we're dealing with the y's, we leave the x coefficients exactly as they were. So these were A1 and A2. Again, in finding the determinant of this 2 by 2 matrix, it would be this product minus this product. So A1 C2 minus A2 C1. A1 C2, that product minus A2 C1. And in trying to find out what specifically x and y are going to be, we simply take, for our value of x, we simply take D sub x and divide it by D. So it would be this amount divided by this amount would give us our x. And just as you may imagine, for the y variable, that's going to basically be the solution to the system of equations, the y coordinate, it's going to be D sub y divided by D. So it's relatively simple. It's just I guess the hardest part is remembering how to set up D sub x, and D sub y, and that's relatively simple. Coefficient matrix is D. I replace the x coefficients with the constants for D sub x. I replace the y coefficients with the constants for d sub y. Okay, so let's actually try to look at a specific example and see if it works for us. Okay, I'm going to do this. Let's see if this works. Bear with me here. All right, how's that? Okay. All right, this way we can see both of them. All right, I just thought of that. Cool. All right, let's see if we can try to solve the system of equations of, let's say we have 5x minus 2y. Let's say that equals 4. And let's also have a second equation of 3 times x minus y equals 9. Sorry, let's make that 3x plus y equals 9. Okay? All right, so you can see this would be A1, 5 would be A1, negative 2 would be B1, 4 would be C1, 3 would be A2, 1 is the coefficient on this y, because there's one of them, would be B2, and 9 would be C2. So, here to find D, our determinant of the coefficient matrix, we just put in our coefficients. 5, negative 2, 3, and 1. So, this diagonal, product of this diagonal minus the product of this diagonal. So that looks like 5 times 1 minus 3 times negative 2. Okay? So, it's always this diagonal, the product of this diagonal, minus the product of this diagonal. And in some cases, we're going to end up subtracting a negative number. So you see that this is 5 minus negative 6 would be 5 plus 6. That gives us 11. So we just found out what D was, 11. Okay, D sub x. Well, that we take and we replace the x coefficients with our constants. So here where we had 5 and 3, we're going to replace them with 4 and 9. 4 here, 9 here. These, since we're not dealing with the y's, we're dealing with the x's, the y coefficients stay exactly the same. Namely, negative 2 and 1. So let's see what this determinant is. 4 times 1 minus 9 times negative 2. So, this looks like 4 minus negative 18 is 4 plus 18. That looks to be, what? 22. 22, I was going to say 32, but 22. Okay? All right, so we have D sub, or just D, we have D sub x. Now we need to find out what D sub y is. And again, since we're dealing with the y's, we get rid of the y coefficients and replace them with the constants. So these two are gone, replaced by these two. So let's put those in right away. Here's the 4 and the 9. Here we put the 4 and the 9 because we're dealing with the x. Here we put the 4 and the 9 because we're dealing with the y. That's the way I remember it. And then these stay the same as they were originally. 5 and 3. 5 and 3. Okay, let's see what we get. Did I do this correctly? These stayed the same. These were replaced by these since we were dealing with the y's. So 5 times 9 minus 3 times 4. That gives us, what is that? 45 minus 12, is that correct? 45 minus 12 is 33. 33. Make sure that everybody sees that's a negative. 33. So, from what we've seen so far, we get D of 11, D sub x of 22, and D sub y of 33. Okay, so x is going to be D sub x divided by D. That gives us, what does it give us? 22 divided by 11. 22 divided by 11, that's 2. So if we've done this correctly, x here should be x here should be 2. So I'll put this up here. So we can check it here in a second. So here's our y value, which is going to be d sub y divided by d. So d sub y is 33 divided by d, which is 11. That looks like 3. So let's see if it works. Here's 3 for y, and here's 2 for x. So let's see. 5 times 2 minus 2 times 3, that looks like 10 minus 6, that's 4. That checks out. Great. Now let's try the bottom equation. 3 times 2 plus 1 times 3, let's see what that equals. That looks like 6 plus 3, that's equal to 9. So this checks out as well. So basically we were able to use Cramer's rule to solve the system of equations. Does it make sense?